Can you hear me?
Okay, finally. Okay. Yes, we do.
Okay, so I'm going to talk about DNS measurements with RIPE Atlas. DNS domain name system is, excuse me, there is something wrong. Yeah. Apparently I have a small problem. The slides are not behaving properly. Okay. This one? Okay, don't move. So domain name system is a part of the internet infrastructure, but it's a part that is not well known. A lot of people keep forgetting about it because probably it's well hidden, and most of the time it works, but when it doesn't, it's a big problem. So DNS is as necessary as IP, but most IT manager or engineers only think about IP when they do things like studying resilience, studying quality of service, when they investigate what can go wrong and where to put money. DNS is often forgotten. I know a big bank, for instance, which has a HTTP server in 3 different data centers for resilience, but has only 2 name servers for the zone, and they are both in the same rack. And this sort of mistake is quite common. So RIPE Atlas is here very helpful because it can do DNS measurements, like it can do ping on traceroute, and there are many options. You can do almost everything that the DNS protocol allows with RIPE Atlas. So first, if we want to do a measurement with the web interface, it's quite simple. Here we do a measurement to epp.nic.fr. In the case of DNS measurement, the terminology is a bit different because most of the time there is no target per se, because the probe is, excuse me, the slides are moving without me. I don't know what happens, but it goes back and forward, or I don't know why. So this is the right slide. Oh, no. That's very funny, this sort of automatic movement of slides. So there is no target per se, because most of the time when you do a DNS measurement, you use the probe resolver, so you don't have to indicate a specific target. No, this one, don't move. You don't indicate a specific target, you indicate instead a query argument, in that case epp.nic.fr, which is the name we want to know about. In here we have address family IPv4, which means we will ask the resolver over IPv4, but the query type is 4A, meaning we want to know about the IPv6 address of the query argument. Remember that in the case of DNS, you have the address family used to talk to the server and the address family of the data you're interested in. You have also other options. One of them on the lower right side of the screen is set NSID bit, name server identifier, which is very useful. And there are many options that you cannot see on the screen. One you can see is use macro. You can have in the query argument macro such as $P for the probe ID if you want to do funny things. Then when you start this new measurement and when you see the result, you see something like that on the web interface of RIPE Atlas. Be careful because the way it's represented can be disturbing, because the color on the right is the response time of the probe. The color on the right is the response side of the probe. And it does not mean that the result was correct. If you see the third result, for instance, which is displayed here, it's form R, format error, it means, and in that case it's a mistake. The resolver had a problem, but the response was very quick, hence you have a very short response time, and it's in green. Sorry. On the other hand, the first measurement has a very long response time, so it's displayed in red, but actually everything went fine, and the response code was no error. So be careful when you read the result of DNS measurements on the website. It's not always what you think. Of course, you can also do DNS measurements from the API. Here is the example of the JSON data that are actually sent from Atlas client to the Atlas command and control center. You have exactly the same argument, query argument, in that case ns.eu.org, query type, here 4a, set RDBit, which means I want recursive resolution. And one interesting thing are the tags at the end. There are automatic tags automatically put by the RIPE Atlas system from regular tests on the probe. Here it's system resolves A correctly, meaning that the probe uses a resolver that can do DNS measurement and it worked. It's not always the case because the probes, of course, can have broken resolvers. So by including only probes with a working resolver, we can do better tests. We want to test really the DNS, not the resolver of the probe. There are many options that you can add in this JSON data, such as the payload size, RDBit, NSID, etc., etc. I let you read the documentation. Now, how can you use it without talking JSON yourself? You can use, for instance, the official RIPE CLI tool, Magellan, which gives an output which is quite similar to DIG. So here we do measurement DNS with query argument lqdn.net, and then we have a response from several probes. This probe gives this result, and as you see, it's really similar to what you get from DIG. You have the query ID, you have the flags of the answer, you have, of course, the IP v4 address of the query argument, and the IP address of the resolver that you used, which is in that case a private address, because of course most of the time the probe uses a resolver. If you use a IPv4 to talk to the resolver, most of the time you will get a private address. The resolver is only for internal use. Magellan is great because you have an output which is very similar to DIG, which is a good thing for most DNS people that are used to DIG. But sometimes I want to have something more synthetical with data like average and median. Then I developed a tool, Atlas Resolved, which uses the same API, of course. And here you can see a request with type AAAA for A, IPv6. We select probes only in France, country.fr. That's one of the great things about RIPE Atlas. You can select probes based on various criteria like AS country. And here we see that 9 of the 10 requested probes replied and all give the same IP address. This is great. We display the measurement ID and of course the date and time, because the internet is always changing, so knowing the date and time of measurement is absolutely necessary. Now there are a few traps when you measure DNS. Remember that by default you use the resolver of the probe. You can change it to talk directly to another server, but by default it's a resolver of the probe, and some probes use resolvers that can be seen as strange, for instance, because they use alternative routes like AFNIC. Sometimes they are behind a lying resolver. So for instance, when you try a domain name that does not exist, sometimes you still get a response because there is a lying resolver. And even if the resolver is perfect, some networks intercept and rewrite DNS traffic. It's the case in France with Bouygues Telecom, for instance. There is a transparent proxy running on port 53. So even if you instruct the probes to talk directly to a server of your choice, the response may still be modified. So what are the examples of use? What's the point of doing DNS measurement? You can measure censorship. That's where it's great to select probes by country. When you want to test routing problem, you typically select probes by autonomous system because it's a relevant criteria. But when you want to measure censorship, selecting probes by country is typically better. A small warning, it may raise ethical issue, because let's imagine that someone, a volunteer, hosts a probe in Saudi Arabia, and then you instruct the probes to do requests for Pornhub.com, for instance, it may be a problem if DNS requests are monitoring in his country. That's one example of the possible ethical issues that Kevin mentioned at the beginning about HTTP requests. At this time, DNS requests are typically not as closely as monitored as HTTP requests, but it may change in the future. Another very good use of RIPE Atlas is to check the different instances of Anycast server, because that's where Atlas is great. If the server is unicast, any request from anywhere in the world will go to the same server. On the other hand, if the server is anycasted, some probes will go to a specific instance, some to another one, and it's very useful to check, for instance, if there is a discrepancy between the instance of the server. And of course, you can test that your domain name results from everywhere, which is really important, because it's necessary to assert that your online presence is okay. Many zones, for instance, have all the eggs in the same basket. For instance, on Sunday, I was testing a problem with a domain name which worked from everywhere in the world, but one big ISP in France. Actually, it was that the domain name was hosted on two name servers, both in the same /28, so probably very close network-wise, and there was a routing issue with a specific provider preventing access to both name servers, meaning that the domain was unusable. So it's really important when you care about your online presence to test using RIPE Atlas or a similar system that it works from everywhere. There are many other things to talk about, but there are also a lot of interesting talks after mine. So if there are any questions, you can go now.
I haven't seen any question coming up being written, but I do have one for you, Stephane. So you mentioned your tool, and I've seen some of your tools being presented by you in also on many mailing lists, where you expose a problem by showing that you wrote a tool to see that. Are your tools available somewhere? Like is the source code available? Can we find them on GitHub, for example?
Yes, it's available on GitHub. There is two repositories on GitHub for RIPE Atlas tools. One is the official one maintained by the RIPE NCC with tools like Magellan, Sagan, Cousteau, and so on. And the other one is a contrib repository managed by community, and this one has been documented in one of my papers on the labs.ripe.net website. There is one article by me explaining how to install my tools. Unfortunately, I was too lazy to provide a proper installation process, so it's a bit manually, but it works. And there are also, in this contrib repository, there are also many other tools which have nothing to do with me. For instance, there is a very good one to transform a JSON traceroute result into a proper traceroute with looking up the alias, the name in UIs, etc., etc. Very great tool.
Good to know. So we will I'll get the links to the repositories, and I will post them in a moment. In the meantime, thank you very much, Stephane, for your presentation. Now we will move over to Shane. Shane will give us a wider area presentation about DNS, and the title is a whirlwind introduction to DNS and RIPE Atlas. So I'll let him talk now, and enjoy the presentation.
Okay, good day, everyone. So my name is Shane, and I will be giving you a presentation about DNS and Atlas. This is a little bit higher level than Stephane's presentation. Covers some of the same areas, and we'll also cover a little bit of the stuff that's in the presentation after this. So I don't have any diagrams in my presentation, so I put some in the first page here to show you a little bit of how the DNS works. And I'm going to start off talking about DNS, Anycast, and RIPE Atlas. So Stephane mentioned that RIPE Atlas is a really good tool for dealing with you were stuck. I think it's better if you just use my laptop for the presentation.
We're having small technical issues with the laptop, with Shane's laptop, so we're moving to my laptop for the presentation. Just give us a moment. I will just download the slides from Shane, and I will give you the download that one. Yes, just bear with me for a moment. I will start sharing my laptop in a second. Yes. 1 second. Bear with me for a moment. I will start sharing my laptop. Yeah. Just bear with me for a moment. Type. Okay. Just bear with me for a moment. So, Shane, come over here. So the slides will be here. Actually, so desktop. So the slides will be here.
Okay. Hello. Try this again here. Okay. Hello. Yes, sir.
I'll share my screen. 1 moment. There we go. I'll share my screen.
Okay. Try this again. Right. So we got ourselves a picture of the DNS. So on the upper left here, we see the typical explanation of how the DNS works. We got ourselves trying to look up like a mail server. You start at the root, go down to the TLD, and then move down to the next one. This actually hides a lot of complexity. In the DNS, each of those authorities may actually have a huge number of IP addresses behind it. So, for example, in the case of root, there's actually 26 IP addresses now, and each domain underneath that may have separate IP addresses and so on. So it's actually a much more complicated picture than that. And drilling down even further, if you look at this other one, each of those IP addresses may be Anycast, which means that it may originate from hundreds of sites all around the world. So what does this mean? Well, it means in DNS we have lots of servers. So as we know, DNS is how we look up names on the internet. We have recursive resolvers, which are the machines that do all the work of actually trying to figure out what information is where. And so they talk to the authoritative servers to actually do the lookups. And as I mentioned on the previous slide, each of these servers may have many IP addresses. And this is good because it provides redundancy. As Stephane mentioned about this server in France that had everything on a single /28, it's like no actual redundancy. But if you do it right, you can have lots of good redundancy there. And it also provides better performance because DNS has something called the round-trip time measurement, which is where the resolvers will basically try to pick the fastest server depending on where they're at. So that's good. In order to deliver service worldwide, we need many, many servers because people live continents away, and you want to not only handle the load, but also the speed of light problems of making things slower. On the other hand, if you have too many servers, the way that this RTT stuff works today can actually slow it down. You can imagine if you have a list of 10 different places to check to see which is the fastest, it actually takes work to check all of them. And that's what we end up with RTT, is that resolvers, if you give them too many places to check, they'll actually work against you in terms of getting the best performance. So, well, what does this all mean? Well, in the DNS, we love anycasting. We love to use the same IP addresses from different locations because that gets around some of the problems that we have with the RTT algorithm. Because instead of your servers having to try 10 different places, we rely on the routing system. So BGP is the routing system used on the internet, and it provides a way to get some measurement, some metric of what it means to be close to things. So what we do in the DNS is we kind of rely on the routing system to solve this problem for us. Now, this was first done in the case of root servers because there's only a limited number of IP addresses, and at the time it was introduced, we couldn't add any more IP addresses. That was the thinking. And the root server has always been under attack at a certain level, and the attacks were increasing. So we needed to get more servers. We couldn't add more IP addresses, so we started anycasting. And it really solved a problem. And it was so successful that we started using it for TLDs, and now we use it for any domain in the internet, may use anycasting. On the other hand, anycast is a real pain. We hate anycast. When you have anycasting, all of your servers look exactly the same, no matter where you are on the internet. That's the design, that's the goal. Unfortunately, what that means is that as a user or an operator, you don't really know which server you're connecting to. It makes it difficult for operators to debug problems. You don't know which server a user is actually talking to. It's also difficult to know if your service is working at all, because it may appear to work from all of your measurement sites and all of your NOCs and things like that, but that is very different from what the users may actually be seeing. Companies that do wide-scale anycasting very rarely have that many network operations centers. So what does this mean for RIPE Atlas? Well, RIPE Atlas has a large number of dedicated probes, and they all have lots of tools for DNS measurements. And what this means is that you can create new measurements, and you can use the existing measurements, and it will help you if you're doing anycasting in DNS, because you can see what potentially customers will see. You can see problems before your users will see them. You can also look for performance differences, and you can look for things like different results, inconsistent data, because of course, if you have hundreds of different sites, making sure the data is all synchronized also becomes a problem, and RIPE Atlas can help you monitor and detect problems with all that stuff. So it's a very effective tool for people running anycast networks, which at scale, DNS today kind of depends on that. So as Stephane mentioned, RIPE Atlas has lots of knobs that you can use for tweaking this stuff. No matter whether you're anycasting or not in the DNS, there's always something you can do. It sort of does IPv4, IPv6, which are the main IP versions on the internet today. It can use UDP and TCP. UDP is the main mechanism for DNS, but when you start using larger packets, DNS will also use TCP. You can ask for name server information. You can tweak buffer sizes. This is very important to discover problems with fragmentation and exceeding maximum packet sizes on the network and things like that. And you can also make sure DNSSEC is working. Although I don't believe RIPE Atlas validates that information, you can get it and you can at least confirm that the correct information is arriving. Now, while there are lots of knobs and there are lots of ways that you can tweak the measurements to match the way you want them to work, there may be sometimes you don't have to do that. RIPE Atlas has many existing measurements already, and most of them are DNS. You can use the web interface right now. I put a URL in the slides, which you can see. You can click on that. That will give you a list of all the predefined, the built-in measurements, they're called. And there are like 12 pages of them. So there's a whole lot of them. And if you want to get a better visualization of them, there's the DNS Mon page, which provides nice green, yellow, red type blocks so you can get a kind of overview of what the DNS looks like for many of these existing measurements. And if you want to do more serious analysis, like you want to do some pattern matching, or you want to look for specific problems in specific regions and things like that, you can also use the JSON API. And in that case, you'll get it, and you can use simple things like Python or R to manage it. Or if you want to do a lot of data processing, you can use faster programming languages and things like that. And finally, there are also existing measurements for ping and for traceroute. These are sort of lower level network measurements, but these are also very useful in the context of DNS as well, because of course DNS relies on the network working, and so having these measurements available can also give you hints about other problems as well. There's going to be a presentation right after this one about Domain Mon, but Domain Mon is a very useful tool. It provides visualization similar to DNS Mon. Use it on your own. I'm not going to go into this anymore. I think my main takeaway from this is that it's very useful for your NOC. If you've got a network operations center, it's often really handy to have a URL that they can go to just get a high-level view of what's going on and say green is good or not. It's also really useful for presentations if you're going to do it, especially for customers and management. People like to be able to see things. Humans are visual, and having pretty graphics is really good, and Domain Mon is great for that. My final slide, and I'll conclude on this, is about one of the drawbacks and limitations of Atlas today in the context of using it for monitoring DNS. So the way Atlas works today is if you want to perform your own measurement, which is to say you're not going to use one of the pre-existing measurements with one of the built-ins, you need to spend credits. The way you get these credits is by hosting probes, anchors, or there's other ways you can get credits by helping RIPE in their Atlas project. However, if you have a large-scale deployment, you're never going to have enough credits from RIPE Atlas to use it for full monitoring. So what this means is just that the economic model doesn't work out. You're going to spend more credits than you get. It's not necessarily a problem. RIPE Atlas is an excellent tool for research, for monitoring small deployments, and you can use it as an extra source of information, or just to confirm theories that you have about your thing, or an independent resource. For example, if you want to do an audit of your DNS system, it's good to use RIPE Atlas for that kind of thing. But at the bottom line is that if you want to use it for monitoring, you're going to also need to use other tools for your DNS monitoring. And that's it. So I guess we can ask for questions if there are any.
Yes.
I don't think they can hear you. So.
No, one second.
Yeah.
There haven't been questions.
No questions.
No questions I've seen. But while you were presenting, Stephane said that there was a problem with a.rootservers.net.
Okay. Yeah.
So it seems like you triggered something during the presentation.
Right. This is bad karma for me, coming back as a DNS person, IPv6 breaking, no good.
Yeah.
All right.
Yeah,
well, thank you, everyone. Yeah.
If there are no questions, then I can get this back over here, and I can introduce Christopher. So far, we have seen two presentations which gave an overview of what you can do with RIPE Atlas. Regarding DNS, we had a presentation which also introduced DNS as well. But here we're going to present a tool that comes directly from the RIPE NCC. It was developed here by the R&D department. And Christopher is one of the minds behind the tool, behind also RIPE Atlas. So I'll let him talk about Domain Mon.
Okay. Is it good? Can you hear me? Great. Well, hi everyone. So I'd like to talk today about Domain Mon, which is a tool which is built on RIPE Atlas. It's part of RIPE Atlas, and it's usable by any RIPE Atlas user, which pretty much means anyone, or at least anyone with credits. So the point of Domain Mon is it allows you to monitor the name servers for your domain or for a domain. It provides a visualization which Shane just mentioned DNS Mon. It's the same visualization, and you can put it on your monitoring screen in your NOC. You can use it in reports to customers, your boss's boss, or you can use it for interactive analysis of problems. You can actually drill into the data and get more kind of depth. It's based on DNS Mon, and I'll just mention that again in a second. And the key thing is it's really easy to set up. You will be creating RIPE Atlas measurements, and they're run using RIPE Atlas credits, but you basically don't have to think about that. All you have to know is your own domain name. So DNS Mon, as Shane mentioned, it's used for monitoring root servers, the name servers of the root zone, and kind of important TLDs or CCTLDs and a few others. And the idea of it is that it's a service provided by the NCC to monitor the critical DNS infrastructure of the internet. And we've had it for some time. There was a version a long time ago, and it was rewritten to use RIPE Atlas a couple of years ago. And it's really valued by root operators, TLD operators. And we really wanted to kind of take this concept and allow ordinary RIPE Atlas users or members or community members to leverage the same kind of abilities. So enter Domain Mon. So it's like DNS Mon, but there are a few differences. Now, DNS Mon, it runs as the RIPE NCC, so there's no credit expenditure, or there is notionally, but it doesn't really come into it. DNS Mon is run from a fixed set of RIPE Atlas anchors, whereas with Domain Mon, you can choose which probes your domain is monitored with. It can be anchors, it can be probes, but you can really specify for your domain what the sample of probes you want to be. And it's designed for any domain, any zone. So ripe.net, anything like that, not just TLDs. Okay, so I'm going to show you kind of a brief walkthrough of how to use this tool. Okay, so I'm in the measurements and tools section of the RIPE Atlas website. DomainMON is one of the tools. So this is the homepage of DomainMON. I've already started monitoring some domains, so it will look a bit different to you if you haven't, but you'll still get this shiny green button to monitor a domain. You click on that, and then all you need to know is what zone you want to monitor. And it should be your zone. It shouldn't be a subdomain. So what I mean by that, if I put something like subdomain example.com, yeah, that's better. If I put something like this, now in the background, the tool has done an NS DNS lookup for this domain, and of course there isn't anything, but it's detected, okay, well, probably you meant the actual zone, example.com, and in this case, I think it's right. So I say yes, okay. And then it looks up what are the name servers for your zone. So in this case, there are two NS records, and it sees, okay, each of those NS records has an A record and a quad A record, so it knows the IP addresses. Now you can just accept this. If you know it to be correct, you can just press next, or you can customize it if you know better. For instance, let's say I'm only responsible for managing the top server here, then I can disable the other one. And let's say I know that I want to add a custom server. So you can customize the set of servers. Now I press next, and then I can really configure what's going to be running against these servers. So you see the servers I've already defined. That's fine. But you can also customize the set of probes that your measurements are going to run from. So by default, it's going to be 10 probes from WW, means worldwide, but you can go into more details. And this is really a simplified version of the RIPE Atlas form. So, and most of the things you can do when you're specifying any RIPE Atlas measurement, you can do here, but it's kind of simplified. But for instance, I've chosen 10 probes from a particular ASN. I want to choose another 10 probes from a particular prefix, and let's say some probes from a particular country. And you can see whenever I change these properties, then we end up getting changes. Well, okay, demo effect. But in general, the cost on the right-hand side is also updated, because that tells you how many credits you're going to be spending on these measurements. The final thing is you choose which measurements to run. So the options are UDP SOA, TCP SOA, ICMP traceroute. You need one of the SOA measurements in order to be useful. So by default, it would be UDP, because that's the most common protocol. But it's up to you. You can include TCP as well, and you can include traceroute, and that's not going to be monitored by the visualization, but it provides an extra layer of information so that if you're debugging problems, you have access to the paths of traffic. So in this case, let's say I just want all of them. I'll use custom intervals, and that generally that will update the cost summary here, and it will tell you how many credits this is going to cost you, when you would run out of credits, and so on. So if I press monitor, I'll choose a more populated country. Let's go for a big one. Right, so I say monitor, and it's now created a new domain for me, new DomainMON domain. And you can see it gives an estimate of how many credits this is going to cost per day. It's quite a lot of credits, as you can see. And it's created RIPE Atlas measurements. So it's created 12 RIPE Atlas measurements. And you can actually see what the measurements are at the bottom here. And you can see that they all have measurement IDs. And actually, these are clickable links back to the RIPE Atlas main measurements website. And each one of these is an ordinary RIPE Atlas DNS measurement. And anything that Stephane was talking about earlier, about what you can see with measurements like results and probes, each one of these provides you that functionality, and you can click through. So if you want to, that's there. If you're not interested, you don't even have to look at it. You can see also that it highlights servers which are not included in the monitoring, but could be or should be. And that makes sense because we chose not to include this server. And also, it's telling us, well, you're monitoring this server, but this is not actually an NS record for this domain. Now, the main meat of DomainMON is the visualization. So you would go here and click visualize. Because I've only just created this domain, then that's not going to be very interesting because there are no results. But here's one I made earlier. So this is monitoring for RIPE.net. There are many more name servers, but it's the same principle. So now if I click visualize, it opens the visualization. Now, as mentioned before, this is the same visualization as DNS Mon. So this is kind of included in various NOCs for root server operators and TLD operators around the world. And you can do the same. So there's a few ways you can use it. You can use it on your monitoring screen. There's a full screen button, so you can make it take up the whole screen. And there's a button which will keep it continually refreshed. So you can start to see problems sort of as they arrive. You can use it to get an overview of the history of your domain. So you can see there's a timeline at the bottom, and this is really the timeline of your domain ever since it was monitored by Domain Mon. So that can be really useful if you're trying to work out changes over time. Say you've made some improvements to some of your name servers, you can prove that response times, and easily visualize that response times have improved or packet loss has decreased or so on. So the main principle of DomainMON and DNSMON is green squares good, red squares bad, which makes it quite useful for the sort of monitoring screen. At the moment, everything is green, which by definition is good, but you have this threshold up here, which you can change because this is already set at 66% unanswered queries is green. Many of you will say, well, if that was happening, I'd be getting phone calls. So you can change it as you wish. So now I changed it to 2%. You can see it's still pretty green, but there are a few kind of aberrations. So what you can do if you're interested in finding the cause of things, you can drill down, you can select a time range, or you can select a server. So in this case, let's select a particular name server. So now rather than seeing the aggregated results of all the probes, you actually see a line for each probe. And I can see in this case, well, yeah, there were problems, but it was only from one particular probe. And in this case, it was a particular probe in the US. So it could be that this probe is having problems. So this is a way to kind of distinguish, is there a problem with the name server or is there a problem with a particular probe? Now, another thing that's useful is to be able to share this with other people. What you can do is you can click on share here, and all this really does is show you the URL of the page. Now this URL is publicly viewable as long as you provide it. So if you don't tell anyone on this URL, this is a hash which only the system knows. So if you share this, anyone can see it. If you don't share it, it's just for you. So that's your choice. Okay, I'd just like to go back to the management screen just for one more thing. So we created example.com. We started monitoring example.com without including the b.inaservers.net. But let's say we want to add that at a later time, or let's say we've just added c.inaservers or something else. So DomainMON makes it easy to keep up to date with changes to your zone. All you do is you come to this page. Let's say I'm no longer interested in using the RIPE NCC server, so I stop measuring those. That will immediately send measurement stop requests to RIPE Atlas. So it's really easy to stop measuring things. It's as easy as to start measuring things. But let's say now I want to measure B as well. So basically, I want to synchronize with the reality that's seen in the DNS. So essentially, it's the same wizard as before, except now we're already monitoring some servers, but it's found out the diff between real life and what we're doing. So it says, okay, probably you want B. Again, you can add manual ones if you want to, but now I'm feeling strictly orthodox. I'm gonna just go with what it says. So by default, it will prompt you to use exactly the same configuration as you've used before. So within RIPE Atlas in general, it's possible to say when you create a new measurement to say use the same probes as a previous measurement. And that's the default here, but if you want to, you can override it and change the probes. I'm going to stay with the default. Same deal for the measurements. By default, it's going to use the same measurements, types, and intervals as you used before. I'm happy with that, but I could change it if I wanted to. And it will tell you the updated credits. So let's say monitor, and it's immediately added it, and you can see that now everything is kind of synchronized and up to date, and you are monitoring your zone. One last thing, you see here the group ID. I'm not going to go into details on this, but this is actually essential when you want to embed the visualization into your monitoring screens or anywhere else. And Massimo Candela has a presentation about this after the break, so he will be talking about embedding various Atlas tools in your own monitoring. So in summary, you should start monitoring your domain now with Domain Mon. You can stop it whenever you want to. It's easy to start monitoring, it's easy to stop. You can start it and then stop it and then start it again in a month. It's up to you. Just keep in mind, you need to let it run for a while in order to get useful visualizations. And just give it a go. Use Domain Mon in your monitoring screens. Use it in your analysis. If there's a problem, drill into the details. If you're producing a report, you can take screenshots, you can share links. There are permalinks that you can use. And yeah, just give it a go. Just see how it can be integrated into your kind of daily work. And please provide feedback. We really want to get an idea of how people are using it. Any suggestions for how it could be improved or changed, or anything that could be added. And you can email us or you can tweet us. Okay, so I think that's everything. So if anybody has any questions, I'll be happy to answer them.
I Okay, I haven't seen any questions. Oh, here it is one. All the measurements which are automatically created are public measurements.
Yeah, that's correct. All the measurements which are created. But the domain yeah, that's correct. All the measurements which are created are public. But the domain mon visualization itself is only visible to people who know the group ID.
Okay.
So I mean,
so if we don't have any more questions, then we're finished, and we're finished
unless you know what
pretty early. So there's almost an hour of break now until the next session. So maybe enjoy lunch. We'll see you again at it's going to be 1:30 if you're in Central Europe, or 11:30 if it's UTC. I hope you enjoyed this session about DNS. I'll make sure I will upload the slides from Christopher as well, because they are the only ones that are missing at the moment from the session. But thank you very much for being here. We'll see you later then. Thank you very much.